In this video, we're going to talk about partial fractions. So, what are partial fractions? So, partial fractions are actually the fractions that you can add to give you something. So, for example, if you have a fraction, let's say 2x plus 1 over x plus 2, given as x minus 1 as a complete fraction. So, the fractions that you can add to give you this are what we call partial fractions. So it's very important to understand how to split that. How do we take this into that form? So that is basically what we're going to study in this video. So I've got a number of questions to help us understand. So this is the most basic and simplest form. Then there is also what we call a repeated factor, where you have a square down there. How do you get to split it? Then we also have another form there. Then where also you have a quadratic function or a polynomial function as part of your denominator, how do you get to show it? Then we also have an improper fraction where you have got another power on top. How do you get to express that one? And also that one there. So these are the questions that we're going to look at. Okay, so let's start. So basically I had to start with this part to show you, to remind you what you already know. So basically when you are given to add these guys, how do you get to go about it? So you find what we call the common denominator, which is going to be a product of the denominator as well. So what we have is x minus 3 multiplied by 2x plus 1. Okay, so we have our common denominator there. So if you divide this term into that part, the like parts are going to cancel out. You remain with this opposite part. So you have 2 being multiplied by 2x plus 1 minus, if you divide this into the entire thing, you are going to remain with the opposite side. So you have 1 being multiplied by x minus 3. So at that point, what do we have on top there? So we have 2 being multiplied by 2x, which is basically 4x plus 2. Negative 1 by the x is minus x. By the negative 3 is a plus 3 over what? Over our denominator as well. So at that point we can simplify it. Favor, we can simplify it. So what we have, 4x minus x is basically 3x. 2 plus 3 is basically a 5 over what? X minus 3, 2x plus 1. So this is the way we get to add partial fractions. Now, under the study of partial fractions, we're interested in reversing this to that form. That is what we're interested in. So how do you go about it? That is basically what we're going to talk about. So what we need to understand is you have to come up with a form that is going to help you out. So let me move this one this side so that we show or prove that we are able to reverse it. So basically in this, we understand that basically these are supposed to be individual denominators. So we'll split them, then we'll put another one there. So we'll put an addition sign in between. Then we'll say we don't know our numerator, so we can put a there and b to represent them. So that is the way you get to work it out. So from this point, you can multiply by the denominator throughout. So on the left, if you multiply by the denominator, so we are multiplying the entire equation by the denominator. So if you multiply this part, it's going to divide. So on the left, what is going to remain will be 3x plus 5. Then at this point where you have x minus 3 on the denominator, it is going to cancel out the x minus 3. So we are going to remain with a being multiplied by 2x plus 1. Then the other side that will cancel out, you're going to remain with b being multiplied by what? X minus 3. Alright. So at this point now what we have is, we're trying to find the value of a and b. So the only way to go about to simplify that is just by coming up with something that will eliminate one of the two. So for example, we have x minus 3 in brackets. So we want that to be equal to a 0. So x minus 3 is equal to 0 when x is basically equal to a 3. So we'll say, okay, let our value of x be equal to a 3 there. So plug in. So where there is x, we'll put a 3. It will be 9 So it will be 3 multiplied by 3 plus 5 being equal to this part where there is x, we put a 3 there, it will be 6x plus 1, 7. So we have 7m. Then this part is going to be a 0, so it will be cancelled out. So 3 by 3 there is going to give us a 9. A 9 plus 5, we have a 14, is equal to 7m. So our value of a has been found to be what? Has been found to be a 2. Then we can also equally find our value of b by coming up with something that will eliminate the a there. So you equate the 2x plus 1 to a 0. So 2x plus 1 is equal to 0. So 2x is equal to negative 1. So x is negative 1 over 2. So we can work with x being equal to negative 1 over 2. So we can plug in. So at this point where we have a 3, we put a negative 1 over 2. It will be negative 3 over 2 plus 5 equal to, this part is going to become a 0, because negative 1 over 2 by a 2 is going to be a negative 1 plus a 1 will be a 0. So this part will be eliminated. Then the other part where we have a b, so we put a negative 1 over 2. So we have a negative 1 over 2 minus 3. Then we have b outside there. Okay. So at this point, to simplify it, we can multiply the entire equation by a 2. So if we multiply by a 2 this side, we have a negative 3 plus 10. Then where we have a negative 1 over 2 there, it will be a negative 1. Then here we have a minus 6. Then remember outside we have a b. Okay. So at that point, what do we have? Negative 3 plus 10 is basically a 7. Then the other side, what we have is negative 1 minus 6, which is also negative 7, b. So our b is basically negative 1. So we found our values of a and b. So remember what we came up with, our form was basically a over x minus 3, then our b over 2x plus 1. So now that we found our values of a and b, our a is 2, our b is a minus 1, so this will become a negative. So this is basically the way you go about it, and it's basically that's what we had initially before even subtracting. So this is an introductory. So this is an introduction to partial fractions. Okay, so we have another question there. 3x over that. So we're trying to split this into its partial fractions. So what we'll do is just say, okay, we have a over x minus 1 plus another part will have this. So we have b over what? 2x plus 1. So we need to multiply the entire equation by this denominator throughout. So on the left, we're just going to have 3x equal to, the other side, this will cancel out with that. So we remain with a being multiplied by 2x plus 1. Then the other side, we have b being multiplied by x minus 1. Okay, so at that point, our goal is to find the value of a and the value of b. So what can we do? So think of something that can eliminate your b there. So when x is equal to 1, obviously, so let x be equal to 1. So there we have a 3 at that point. So at this point where you have a, if you put a 1 where there's a 2, it is going to be a 3 inside there. So our a is basically going to be a 1. For us to find the value of b, we have to eliminate a there. So what value can you put where there is x there to make it a 0? It's going to be negative 1 over 2. Negative 1 over 2 by 2 is going to be a negative 1 plus a 1 is 0. So this part multiplied by, so we are saying let our x be equal to negative 1 over 2. So that part will be negative 3 over 2. And this part will be a 0. That part is going to be b, then where is x, we're putting a negative 1 over 2. So we basically have negative 3 over 2. Because if you say, okay, negative 1 over 2 minus 1 there. So you come up with a common denominator of 2. This is what you're going to have. So we've seen that the coefficients are the same, and therefore we can just make a conclusion to say our b is equal to 1 as well. So basically we found our values of a and b. We can just put in there. we can just now substitute in and you'll be able to get our solution. Okay, so our A is therefore 1, our B is also what? Is also a 1. So we found that. So you can try it out to see if it is going to come out. So what you can do is, the common denominator is going to be x minus 1 and 2x plus 1. So multiply this, divide that into this part, you will remain with that, 2x plus 1. Then do the same the other side, you're going to remain with x minus 1. So basically, this will cancel out. 2x plus x is basically 3x, and therefore you've proven that what you found as your partial fractions is true. What happens if you have what you call repeating factor, where you've got a square there on the denominator? How do you go about it in this case? So in this case, it becomes a bit different because it requires you to come up with 3 different partial fractions. So the first one will be a over x minus 1. So I'll ignore the power there initially. I'll ignore the power. Then I'll come up with another part, which will be x minus 1. Now this time around showing the power. And the other part c, which is just going to be the other factor there. Okay, so this is the procedure that you work with when you're dealing with repeating factors, when you have a power there. Okay, so how do you go about it in this case? So we'll do the same. We'll multiply by this. So when you multiply by that, on the left hand side you remain with 3x plus 1. On the right hand side, remember when you say x minus 1, what we are having is x minus 1, x minus 1, x plus 2. This is basically what we are having. So if you multiply with that part there, one of the x minus 1s will go. What are you going to remain with? So you remain with a being multiplied by x minus 1, x plus 2. Okay. Then how about the next term? What we have is x minus 1 squared. So the entire part will be cancelled. You just remain with b being multiplied by x plus 2. Then how about the last part? You only have x plus 2. So the entire part will stand there. So c is going to be multiplied by x minus 1 squared. That's what we have as our equation there. So our goal is to find the value of a, b, and c. So think of some of the things that can eliminate this. So basically, if you let your x to be equal to a 1 there, this part is going to be a 0 and that part will be a 0. So you can plug in. So let's put a 1 there. So we have 3 by 1, 3 plus 1, we have a 4 equal to, at this point it will be a 0. So this entire part will be 0. Then this part is going to be 3b. Then that part where there's a 1 to be a 0. So we found the value of b to be equal to 4 over what? 4 over 3. So we found our b. How do you get to find another one? So think of another value that can eliminate. So if you put a negative 2 there, so let x be equal to negative 2. What do we have on the left? Put a negative 2 there. Negative 2 by 3 is basically going to be a negative 6. Plus a 1, it's the negative 5. So we have a negative 5 being equal to, get the same value of negative 2, plug in the first part. So this is basically going to be a 0. This is going to be a 0. So remain with that part. So we have a c. So where there is x, we put a negative 2. It's basically going to be negative 3 squared, which is basically going to be negative 5 is equal to 9c. So basically our c is going to be negative 5 over 9. So we found our c and our a. Is there any way where we can cancel out our b and c and remain with a? There's no possibility because x minus 1 as well as x plus 2 is part of a. So what we can do at this point is we can try to expand. We can try to expand. We see what we're going to have. So due to lack of enough space, I'll do that. So let's try to expand now. So what happens if you expand this part? So remember on our left hand side what we have is 3x plus a 1 is equal to. So we're trying to expand x minus 1 there. So x minus 1 being multiplied by x plus 2. X by x is what? So we have x squared. X by the 2 there is a 2x. Negative 1 by x is minus x. Negative 1 by 2 is a minus 2. So we have x squared plus x minus 2. So I can show that. So we have a x squared plus x minus 2. That's for the first part. For our b, we have x plus 2. How about our c? Our c, we have x minus 1 squared. So if you expand that, what are you going to have? What you're going to have is going to be x squared minus 2x plus 1. So we can even show that here so that it looks better. So what we're saying, after expanding, what we have is a x squared plus x minus 2 plus, so basically that is our c, sorry. So our b, we have x plus 2. Then for our c, we have x squared plus 2x plus a 1. Okay, so now we can come up with something that is going to help us find the value of a there. So if you check the left hand side, what do we have? At least we have a term that is having x there, so we can get that. So we have 3x being equal to, from our a, what part is having x? Is only x, so it's ax. From our b part, what do we have? We have only x, so plus bx. Then for our c, we have 2x, so we have c2x. So there are some terms that we know in this equation, so we can plug in. So x can divide out and it will be eliminated, so we'll remain with a 3. Our a we don't know. Our b is 4 over 3. Our c is basically what? Negative 5 over 9 multiplied by the 2 there. Our x has been cancelled. So from there you're able to find the value of a. Let's do it now. So what we have, we can multiply by, we can try multiplying by a 9. We see what we're going to have. So multiply the entire equation by a 9. So this part, 9 by 3 is 27. A by 9 is 9a. 4 over 3 multiplied by a 9. So the 3 is going to divide into the 9. It will be a 3. By 4, it will be a 12. So what we had is 4 over 3 multiplied by 9. There it's a 1, there it's a 3. So it's a 12. Then for the other part, we have 5 over 9 multiplied by 9. It's going to be a 5. So we have a minus 10 because of the 2 there. So at this point, on the left, we have 27. Then 12 minus 10 is basically what? It's basically a 2. So we have 27 minus 2 is equal to 9a. So 27 minus 2 is 25, being equal to 9a. So at that point, our value of a is going to be 25 over 9. Okay, so we found the value of a, b, and c. We can now plug in into the equation that we had there, and we'll be able to show it as partial fractions. So what value do we have for a? So for a, we have 25 over 9. So we have 25. So it's going to be over 9, x minus 1. Our b is basically 4 over 3, so we have 4. Then a 3 there. X minus 1 squared. Then for our c is negative 5 over 9, x plus 2. So we've now resolved this into its partial fractions. Okay. The other part is also on the same concept of repeating factors. We can do it so that we understand better. So how do you get to approach this question? So what you're going to do is, you're supposed to say, okay, in this case I expect to have a over x plus 2. I also expect to have b over x plus 2 squared. I also expect to have a c over what? Over x plus 1. So this is only what you're supposed to remember. You repeat that one twice, without a power and also with a power. Okay, so after expanding there, what you're going to have, you have, so you need to multiply by this. So it's just that I don't have enough space. I can write it there. I multiply the first part with it. So for the first part, it's just going to cancel out. So we have 5x squared plus 17x plus a 15 being equal to, for the first part we have x plus 2. So if you multiply this with you multiply the numerator with this part, this is going to cancel out. Remember we said x plus 2 is coming twice. Okay, that's what we have. So one of the x plus 2 is going to cancel out. Then what you're going to remain with is your a being multiplied by x plus 2, x plus 1. Then for your b, what do you have for your b? So for your b, you have x plus 2 squared entirely being cancelled out. You remain with x plus 1. Then for your c, you have x plus 1 being cancelled out. You remain with x plus 2 squared. Okay. So I can even use a different carrier so that you're able to set as a c. Okay. So now that we have that now, at this point, in this case where you have such a polynomial, it's very important that you just expand everything else to 7 times. So we have 5x squared plus 17x plus 15 being equal to, so what do you get if you expand x plus 2 being multiplied by x plus 1? X multiplied by x is basically x squared. X multiplied by x1 by 1 is basically x. 2 by x is 2x. 2 by 1 is a 2. So what you have is x squared plus 3x plus a 2 there. We can indicate that. So we have a x squared plus 3x plus a 2. So for our b, we can't expand it beyond that. So that's x plus 1. Then for our c, where we have that, basically when you get to expand that using the same procedure, you will have x squared plus 4x plus a 4. So we've expanded that. So we can now start. So what you can start with is we can start with x squared. So we get the coefficients of x squared. So on the left we have 5. For this part we only have a. For that part we don't have anything there. That is x squared. Then that part we have cx. So we have a c. So a plus c is equal to 5. Okay, that is our first equation. We can go for our second equation. So go for the 17x. Anything adding a coefficient of x. So we have 17. Then this part we have 3 there. So it's 3a. Then this part we just have x. So it's just a b. Then for the other part we have a 4 there. So it's a 4c. So that is our that's our second equation. Then for our third equation, we're just going to go for all the things that are only having a constant. So 15, we have a 15 there being equal to, this part we have a 2, so it's a 2a. Then the other part, what do we have? So we have a 2a there. At this point we have a b plus. Then what we have for the last part, for our c we have a 4. So what are we going to write it? So say a 4. Okay, so we have a 4 for what? It's a 4c. Okay, so let's create some space on top here. So how are we going to find the value of a, b, and c? So we have 3 equations to help us there. Okay, so I'll start. So my first equation is this. How can I make it? So what I'll do is I'll say, okay, I can make a the subject. So my a is therefore going to be 5 minus c. So I've made a the subject. I can now plug in the other equation there. So I'll have 17 is equal to, where is this a, I'll put that. So it is 3, 5 minus c plus b plus 4c. So if you expand that, you have 17. So 3 by 5 is a 15 minus 3c plus b plus 4c. Correcting the like terms, 17 minus 15 is a 2. Negative 3c plus 4c is a c. Plus what? The middle term that we have is a b there. So c plus b is also equal to 2. Okay. Where is the other equation? The other equation that we have is basically we have 12. Wait a minute. The last equation we have is a 15 is equal to 2a plus b plus 4c. Okay, let's try to move on. Okay, so we know what our a is. So we are saying our a we've put, for our a we've put 5 minus c. So we have 2, 5 minus c. Then for our b, we can make b the subject to be in this case. So our b is going to be 2 minus what? 2 minus c. So where is b, we'll put that. So we have 2 minus c. Then basically we have 4c at the end, 4c. So I believe from that equation we'll be able to find the value of what? Our value of c. So what we have is we have a 15. 2 by 5 is a 10. 2 by c is a minus 2c. Then we have 2 minus c plus 4c. What are the right terms that we have there? So we have negative c plus 4c minus 2c. So we also have a 10. 10 plus 2 is a 12. So what is a 15 minus 12? So negative 2c plus 4c is 2c. 2c minus c is a c. So basically our c is equal to a 3 there. So c is equal to 3. Then remember, after making b the subject, in this case it was 2 minus c. So since we find the value of c, we can plug in. So our b is going to be 2 minus c. So our c is 3, so our b is going to be a minus 1. Then our a is 5 minus c. So 5 minus 2, which is what? A 3. So this is another way that you can use. If you don't want to use the zeros there, you can use this method as well. So we found the value of a, b, and c. All we have to do is just plug in. So our a is what? Our a that we have, we've said it's 5 minus c. So 5 minus 3, which is going to be a 2. Then what do we have for our b? Our value of b is a minus 1. So that sign over there will become a negative. Then what value do we have for our c? Our c is equal to a 3 there. So we've resolved that into the partial fractions. Okay. Another key concept that what we have to understand is basically when you have such an expression where they've given you a polynomial function to be part of a denominator. So it's advisable that you expand it. You get to factorize it. So factorize the x squared plus x plus 1. So what numbers can you multiply? So if you multiply 1 by 1 is a 1. The sum is also a 1. So what numbers can you multiply to give you a 1? You add them, they give you a 1. Is there any possibility there? So basically it's impossible for you to get to factorize that expression. So how do you get to show it? So the other way that you can show it is just by saying this is equal to, you come up with an expression which can be ax plus a b there. Okay, so it's going to be divided by what? X squared plus x plus 1 plus, then the other part of the other component is basically going to be expressed in which way? So it's just going to be a c now over x minus 2. So that is one way that you can approach such a question. So at this point you can multiply by the denominator throughout, and on your left what you're going to have is a 5x. Then at this part where you have ax plus b, how do you get to approach it there? So if you multiply by this entire denominator, this part will cancel out and you remain with it. So you have ax plus b in brackets multiplied by x minus 2. Then that part you're going to remain with a c being multiplied by the opposite parts. Okay, so we can use the previous method that we've worked with by just expanding this. So we basically have 5x being equal to ax multiplied by that x is going to be ax squared. Ax by the 2 is going to be a minus 2ax. B multiplied by x is going to be x. B multiplied by minus 2 is minus 2b. Then the other part we have cx squared plus cx plus a c. So we expanded now. What is very cardinal is to correct the like parts. So correct the x squared and the x squared. So on the left hand side, do we have anything that is having an x squared? No. So we can say it is equivalent to a 0. So 0 is equal to, so we can say 0x squared is equal to ax squared plus cx squared. So what we are saying there is the summation of a plus c is supposed to be equal to a 0. That is our first equation. You can go back to, you can go to a term which is having the x now. So what term is having x? I'll use a brew. So we have that part, we have this part. Okay, so this part is a combination there. Then we also have the cx there. So we have 5 is equal to, so we remove the x out. So we have a negative 2a plus b, then plus a c. So this is another equation that we're going to work with. Then which other equation can we come up with? We can now go back, we can go to a constant. So do we have any constant on the left? There is none, so we'll put a 0 there. For the first part, the constant that we have is a minus 2b, the only term without x. Then the other part, it's a c. So that is another equation that we have. So in such a case, let's even start with that very equation. We can make c to be the subject. So c is going to be equal to 2b. So we found our c, we are able to find our a. So we can go back to that equation. Our a is going to be, so a plus c is equal to 0. So a is equal to negative c if you make it the subject. And so therefore our a is going to be, what is our c? Our c is a negative, our c is a 2b. So it's going to be a minus 2b. So that is an equation relating a and a b. Going back to our first equation, we know that 5 is equal to negative 2a plus b plus c there. So we can now plug in the like terms. So what happens if we use if we try to remain with a b there? Let's try to remain with a b. So 5 is equal to, where there is a, I'll put minus 2b. Then where there's a b, we're trying to remain with a b, so it will remain there. Then our c is equal to 2b. So what do we have? So we have 5 is equal to, that is a 4b plus b plus 2b. At that point, what do we get to have? So what we have is 5 is equal to 4 plus b, there is 5b plus a 2b. So 4 plus 1 is a 5 plus a 2 is a 7b. So basically our b is equal to 5 over what? 5 over a 7. Okay. So remember we say that basically our a is equal to negative 2b. And so therefore our a in this case is going to be what? What is our b? Our b is 5 over 7. Okay. So is it a negative or a positive? So it's a negative. So it's a negative 10 over 7. Okay. That is our a. Our b is 5 over 7. How do we get to find our c? So our c is, we're going to plug in there. So it's going to be, where there's b, we'll put 5 over 7. So it will be 2, 5 over 7. And therefore, note that basically our c is going to come out to be what? Our c is going to be 10 over a 7 there. So we found the value of a, b, and our c. We can now plug in. So looking at our equation there, we have ax plus b. So what is our a? Our a is negative 10. Negative 10 over 7. What is our b? Our b is actually 5 over 7. So we have a common denominator of 7 there. So we can take it to be part of the denominator. So we have, basically, we can say we have negative 10x plus 5 over 7, x squared plus x plus 1. So we had the common denominator of 7 between a and what? A and b. So which one is our a? Our a is basically negative 10. So it's negative 10x plus 5. Then for our c, we have 10 over 7 as well. So it's going to be plus 10 over 7x minus 2. So this is the way you get to convert that to partial fractions. Okay, how about a case where you have an improper fraction? How do you get to approach such a question? You have an improper fraction like that one, where we have 4x to the power 3 plus 10x plus a 4. How do you get to solve such a question? Okay, so you need to understand that the best way of approaching this question is either some people may approach it in this case. If you are more conversant with it, you can say it's basically ax plus b, then you have c over x, then you have d over 2x plus 1. But I don't like people mastering formulas, so it's better you understand where that is all coming from. So basically, if you get to expand what we have is our fraction there. On the denominator, what you're going to have is basically, if you expand it, it will be 2x squared plus x. So you can divide this using long division. Okay. So what is a long division there? We can show it now. So for long division, we have 4x to the power 3 plus 10x plus 4. So we are dividing because this is a division. So our factor is basically 2x squared plus x. So remember, when you are dividing, make sure that what you have there should be decreasing in the right order. Okay, so I'll introduce an imaginary part there. I'll introduce 0x squared because we don't have a squared. Okay, so if you're not so conversant with long division, you can check out our video on that. You'll be able to understand. So we always divide by the highest power. So the term that is having an highest power is a 2x squared. So divide that into that. You have a 2x. Okay. So 2x multiplied by the 2x squared is going to be a 4. A 4x to the power 3 multiplied by the x is basically going to give us what? 2x squared. We'll subtract. So this part will go. So then 0x squared minus 2x squared is just going to be minus 2x squared. We'll divide again that part. It's going to be a minus 1. So you multiply there. What are you going to have? You have a minus 2x squared, a minus x. So subtract. So we have a 10x there. So this is going to be a 0. Then 10x minus x is going to be 11x. So we're remaining with a remainder 4 plus a 4 there. So this is basically where it was all coming from. So after dividing, what are we trying to find? What have we found? So we can say that what is down there is our remainder, then what is on top is how many times we can divide it. So we have 2x minus. So we are saying this is basically equal to 2x minus 1 plus 11x plus 4. That is our remainder over what? Over that part. So over x 2x plus 1, because that is our fact that we are using. Remember, if you divide the 2 into a 7, it's basically 3 times 1 over 2. This is basically what it's saying. So after dividing this part into that part, what are we getting? What we are getting is this part, remainder what is down over what you are dividing with. And that's what we are saying. So this is basically where that equation was coming from, where you come to say, no, it's ax plus b. Then you come and say cx plus b over the factor. So that is one way of which you can approach it. But I feel dividing is easier because you've already gotten your ax plus b there. So then at that point, what you can do is now split the other part into partial fractions, which is going to be way easier. So you have 11x plus 4 over x, then you have 2x plus a 1 there. Okay, what do you have now? So what you have, this is going to be equal to, so we can now say a over x and also b over what? 2x plus 1. So this is easier and to work with. You can multiply by the denominator there. So if you multiply throughout, on your left you remain with 11x plus 4 being equal to, so if this part is going to cancel out, you remain with 2x plus 1. Then for your b part, this term is going to cancel out and remain with your x there. So we are there. Okay, so at this point, what you get to do now, our goal is to find the value of a and also what? And also our b there. So therefore say, we have 11x plus 4 being equal to, so a multiplied by 2x is basically 2ax. Or the other way of approaching, let me try to use a different approach. So what values can you put where there is x there to make it a 0? I'll start with a bx. So you just put a 0 there. So let x be equal to 0. So this part is going to be eliminated. You have a 4. Then where there is a 2, you put a 0 there. Where there is x, you put a 0. So it will just be a 1. So you have a. So your a is equal to 4. So now what value can you put where there is x on a there? Okay. So what value can you put there to make it a 0? So it's negative 1 over 2. So on the left hand side you have negative 11 over 2 plus a 4 is equal to, this part will become a 0, then that part is going to be negative b over 2. So you can multiply by 2 throughout. What you're going to have is negative 11 plus 8 is equal to minus b. So negative 11 plus 8 is basically negative 3, which is equal to negative b. So our b is equal to 3. Okay, so we found our value of b, we found our value of a. We can now plug in. Okay, so what we are saying is, you moving that into its partial fractions, the first part that you have is 2x minus 1 plus, so that part we are saying is a, so 4 over what? 4 over x plus our b is 3 over 2x plus 1. So you've resolved the question into its partial fractions, and that's how you go about it. For the sake of practice, one more question on the same. So this time around we have x to the power 3 plus 1. So go straight into dividing because it's an improper fraction. Okay, how do you get to approach it? So what we have is x plus x squared. Let me show it on top. So we have x squared plus 1 as our factor. We are dividing into 2x to the power 3 plus 1 there. So now, what did we say? You need to make sure that the powers are decreasing in the right order. So we introduce imaginary parts there. So plus 0x squared plus 0x plus a 1. We can start dividing. So this into that is x. Multiply that is x squared plus x. You subtract, you have x there. In this part 0x squared minus minus what? Okay, so it wasn't necessary for us to even okay, so this is where you need to be smart with long division. Okay, so x squared plus 1. So what do we have there? So we have okay, so it goes, you have supposed to look at the left hand side. It's what matters. It's what's going to determine what's going to be there. Because basically, if you divide the x squared into x to the power 3, what are you going to have? You are going to have x. Multiply by that, you have x squared. Multiply by the 1, it's going to be x. So it's very important that what you should have on top should be matching. So you can introduce a 0x there. At this point, we can even show the 1 now. So if you subtract there, basically this is the power 3, sorry, supposed to cancel out. 0x minus x is basically going to be a minus x. Then can you divide? No, you can't divide, so you have a plus 1 there. Okay, so that is our factor. I hope you can clearly see how that has come about. So in this case, what we will say is, okay, the way you can express this one is going to be x as the first part. Your remainder is negative x plus 1. So remainder is negative x plus 1 over what? over the factor, which is basically x squared plus a 1 there. So how do you go about it from that stage? So you have x plus 1, you have x squared plus 1 there. Okay. So now you want to express that into partial fractions. Is there any way that you can move further than that? How do you get to approach it? So you can't expand it more than that, and this is actually your final answer. So you've already split it into its partial fractions. Okay. So this marks the end of the video. I hope you are now able to answer different questions on partial fractions. Thank you very much for watching.